For this example, we're going to calculate f of c using synthetic substitution. We have a polynomial here in front of our semicolon, and then afterwards they tell us for this problem that c is 5. If you're going to calculate f of c, that means you're calculating f of 5. And what we have traditionally done when we've calculated f of a number is we take that number and we plug that back into the x's that are in the original equation. That is not synthetic substitution, but it is a way of doing that problem. Synthetic substitution says this. We're going to use synthetic division to go through and calculate what we would get if we took our number here for c and we plugged in for all of those x's. And here's how that works. We have our polynomial here. It's a 2x to the 6th, so I'm going to put a 2 inside of our synthetic division symbol representing the x to the 6th term. Next, I want an x to the 5th term, and we do have a minus 5, x to the 5th. Next, an x to the 4th term, so a minus 21, x to the 4th gives us a negative 21 here in the next column. Next would come our x cubes, but we don't have any, so I do need to put a 0 there to hold that place. After that would be our x squareds. Again, no x squared term, so I need another 0. Then we have our x term, which is a negative 2, and then our constant term on the end. So when you get synthetic division set up to do your synthetic substitution, this is what it should look like inside of that synthetic division symbol. Typically, when we are dividing by something out here, it is given to us as x plus a number or x minus a number. In which case, when we go through, we need to change the sign to come up with our number here. This is not x plus or x minus a number. They are telling us what this value is. We're dividing by 5. So you don't need to do a sign change on that one because it's not x plus or x minus a number. They're just telling us divide by 5. That process again. Here in our first column we have a 2. Underneath it is nothing, so 2 plus 0 is 2. And I write that on the bottom. Anytime that you write a number on the bottom, for your next step, you're going to take that number, multiply it by the number in front. Whatever that product is, you're going to put that underneath the number in the next column. 2 times 5 is 10. This is a positive 10, so I'm going to be adding in the next step, negative 5 plus 10. That is 5. I just wrote a number down here in the bottom, so I need to multiply by the number in front and put the result here. 5 times 5 is 25. We have a negative 21 plus 25, which is 4. Again, I just wrote a number in the bottom, so I need to multiply that by the number in front, and 4 times 5 is 20. Put that in the next column. It's a positive 20, so I'm going to be adding 0 plus 20. That is 20. 20 times the 5 in front. 20 times 5 is 100. And 0 plus 100 is 100. 5 times that 100 gives me 500. Negative 2 plus 500 is 498. That 498 times the 5 in front is 2,490. And 10 plus 2,490 is 2,500. Typically, you'll see a vertical line separating the last number, which is our remainder, from everything in front, which is our quotient. So there is the synthetic division that would go along with this problem. The directions were to find f of c. So we are calculating f of 5, since c is 5. Traditionally, we would have just taken 5, plugged it into all of those x's, and come up with a number. But there is another way called synthetic substitution, which uses synthetic division. And all you need to know is that your remainder is what you would get when you take 5 and substitute it in for all of those variables. So our final answer for f of 5 is simply 2,500. Your answer, when you do synthetic substitution, is just the remainder. We don't use anything here from our quotient. If you want to check your work and see if you did it right, simply take 5, Plug that in for all of the x's here, and when you raise 5 to all of those powers and multiply and add and subtract, you'll get 2,500 at the end.